Hey guys, this is 11.2, multiplying and dividing rational expressions. So very similar to what we did in 11.1, except instead of just simplifying a single fraction, you will be factoring and then simplifying or canceling two fractions. Complex fraction, here's what it is. I got some in here. Complex fraction is just a fraction that has a fraction inside of it. So super fun when you have a fraction inside of a fraction, either in the top or the bottom or both, like what you see down below here. Here's how we handle it. If you circle the bottom, take the 3/4 that's in the top of the fraction, multiply it by the reciprocal of what we just circled at the bottom. Look to see if there's any canceling, cross-canceling that can be done. There isn't in this case, so we multiply straight across. We've got it. Second example on here, very similar. There will be a little cross-canceling that can happen. You can see with the x's here, I can cancel out, make that x squared. That's just 1. Multiplying straight across gives me 35 x squared over 6. All right, so just multiplying two rational expressions or two fractions together, you look to see if you can factor and cancel first. In this case, we can't, so we multiply straight across. Remember to add the powers when you're multiplying the a squared and the a cubed. Same thing on the second one. Remember that these are in parentheses. Now it's in factored form. Notice that none of the factors match exactly. So nothing simplifies out of this one. So we just write it as a product with all the factors left in factored form in a single fraction. Same thing on the bottom. You can go ahead and pause the video, try the bottom. Pretty similar to the ones above them. And I'll put the solutions up. All right, let's go to the next one here. Now these require some factoring first. So you're going to look at each portion, top or bottom of each fraction. There are two fractions I see up here. So looking at the top of the first fraction, can you factor it any further? We cannot. We're just going to leave it x plus 5. And the bottom one, 7x minus 21, is one of the types of factorings we've been working on. You're going to run into GCF factoring on this. You're going to run into quadratic trinomials that you need to factor to big X. One way to do it. And then you're going to run into factoring of the form a squared minus b squared, or difference of squares on these problems. So you got to decide which type of factoring you see in each portion of the fraction here and then apply it. So remember to factor first before doing any canceling. So on this one, bottom of the first fraction is GCF factoring. We pull out a 7. 7x divided by 7 is x. 21 divided by 7 is 3. The 14x is a monomial term. We're going to leave it alone. The x squared plus 3x minus 10, we are looking for factors of negative 10 that add to equal 3. They are 5 and negative 2, so my factors are x minus x plus 5 and x minus 2. Looking to see what simplifies out. The x plus 5s are gone. 7 goes into 7 once and into 14 twice. So final solution, don't lose that x, will be 2x over x minus 3, x minus 2. Second one, 2m plus 5 just stays 2m plus 5. On the bottom of that first fraction, I can pull out a 3, leaving me a factor of m minus 2. M squared plus m minus 6. I'm looking for factors of negative 6 that add to equal 1. 3 and negative 2. and then the m minus 2's match. So my final solution is 2m plus 5, m plus 3, all over 3. You can go ahead and try the pause the video, try the practice problems. I'll go ahead and put up the solutions. Alright, to go ahead and check those, I'm going to move into some division here. So what I do with division is I'm going to flip and factor in the same step. It looks like this. X squared minus 25 is our a squared minus b squared special pattern here. So when I factor it, it factors as a special product. X plus 5, x minus 5, 4x plus 28. Notice there's no x squared in there. There aren't 3 terms. It's a GCF factoring. 4 and x 7. And then I've got the x minus 5 moves to the bottom. X squared plus 9x plus 14. Quadratic trinomial factors as x plus 2, x plus 7. Go ahead and do your simplifying. So final solution would be x plus 5 times x plus 2 over 4. Second one here, it's probably good to think about this. X squared minus 3x minus 4 is being over 1. First term on there, let's switch colors here. Is a GCF factor and can plot a 3x. Left with x minus 4, 5x. And then times 1 over factor x squared minus 3x minus 4. I'm looking for factors of negative 4 that add to equal negative 3. They are negative 4 and 1. And the x minus 4's cancel out, the x's cancel out. Remember, they cancel equal 1s. So we have 3 over 5 times x plus 1. All right, I'll go ahead and do the practice problems here. The x plus y's cancel out, the x's cancel out, leaving just 1. On the second one, plot a 4. Bottom, you can plot a 2. Turn it into multiplication. The 9x minus 15, plot a 3. X squared plus 6x plus 8, factors of 8 that add to equal 6. X plus 2, x plus 4. X plus 2's cancel, x minus 5's cancel. 4 over 2 equals 2 over 1. So I got 6 over x plus 4. All right, final one is just another case of division. It's written as a complex fraction. So if you circle the bottom, it's just 1 over x minus 2 times the reciprocal of the bottom. And then factor anything that can be factored. And then cancel where appropriate. And that's it. So try the practice one, pause the video, try the practice one, and I'll put the solution up. Remember that there's still a 1 on the top. If you multiply 1 times 1 times 1, a 1 on the top and an x squared on the bottom, and that's it. So please write your summary, finish up those notes, and try the practice problems in the classroom.